Good morning. This is problem number 71, which I am going to show you the solution of. And the problem is integration I is equal to integration of tan x minus tan alpha divided by tan x plus tan alpha dx. So this is the integration we need to perform. Okay. Here the angle alpha, this is a constant and the variable is x. Because dx is there, that means x is the variable. Okay. So we need to perform integration on this expression for x. So first, you write this way. The next step to this is you write tans in terms of sines and coses. Okay. So tan x is equal to sin x by cos x. Similarly, tan alpha is equal to sin alpha by cos alpha. In the denominator, also the same thing, sin x by cos x. Here sin alpha by cos alpha, and this dx is there. Now, so what is the result? Result is, it is equal to sin x cos alpha minus cos x sin alpha, right? In the denominator also same thing, but with a positive sign. This positive sign I was talking about, and cos x sin alpha, right? So this is in the form of sin a cos b minus cos a sin b, and in the denominator the form is sin a cos b plus cos a sin b. Therefore, this is equal to what? Sin x minus alpha, and in the denominator this is sin x plus alpha dx. Right? Now let x plus alpha is equal to z. Therefore, on differentiating both sides of this, we will get dx is equal to dz. Okay. The next step to this I am writing here. Therefore, integration I, this is equal to, in the denominator what is there? Sin z, and in the numerator sin x minus alpha was there. X is what? From here we are getting x is equal to z minus alpha, and already 1 minus alpha was there, so write that also minus alpha. So sin z minus alpha, that is sin z minus 2 alpha. So this is equal to what? Sin z cos 2 alpha minus cos z sin 2 alpha. Alright. This dx is there, this sin z is there. Now in the next step, this divided by this is equal to cos 2 alpha, and cos 2 alpha is a constant, so that can be written outside the integral sign. So cos 2 alpha into integration of, this dx will not be there, here dz will be there, here also dz will be there, okay, because dx is equal to dz. So this is cos 2 alpha, then integration of dz minus this divided by this. So sin 2 alpha is a constant, write that sin 2 alpha outside the integral sign. Then in the denominator sin z is there, and in the numerator what is there? Cos z dz, and cos z dz can be written as d of sin z, right? D of sin z, here I am showing d of sin z is equal to cos z dz. D of sin z is equal to cos z dz. Okay. how this is coming? D of sin z is equal to cos z dz. I think already you know this thing. See, I am showing you here. I am showing you here d of sin z. This can be written as d dz of sin z into dz. Can you write this way? D of sin z is equal to d dz of sin z into dz, and d dz of sin z is nothing but cos z. So cos z dz. So this cos z dz has been replaced by d sin z here. So this is in the form of what? D of x divided by x, dx by x. If you assume sin z is equal to, say, sin z is equal to y, if you assume that sin z is equal to y, then that is in the form of dy by y, integration of dy by y, right? If you assume sin z is equal to y. So this is in that form. So what is integration of dy by y? You know that thing. You know that that is equal to log of y. Similarly, you will get here log of sin z. Okay. So here we are getting z cos 2 alpha, and from here we are getting sin 2 alpha into log of mod sin z. Okay. Plus a constant of integration c. And z is what? Z is x plus alpha. So x plus alpha cos 2 alpha, okay, minus sin 2 alpha log sin x plus alpha plus this c. Okay, now this alpha into cos 2 alpha is a constant quantity, and plus c makes another constant, and say that constant is equal to c. So the ultimate result is x cos 2 alpha minus sin 2 alpha log sin log mod of sin x plus alpha plus c1. C1 is the new constant, which is equal to alpha cos 2 alpha plus c. And in your answer script you must write that, where c1 is equal to c plus alpha cos 2 alpha. You must write. Okay, let me check whether everything is visible or not. Yes, everything is visible. So there is no problem at all. This problem is somewhat lengthy, but I think this is an easy problem. You won't have any difficulties in understanding this problem, okay? Anyway, so this is the end of this lecture. Next we will move to problem number 72 in a new video. Thank you. Thank you for watching this video.